Where we last left off, I had just finished overloading the plus, minus, multiplication, and division operators. But even with that achievement, I still had a bit of a problem. My problem is that in order for me to use these plus, minus, multiplication, and division operators, I need to do them by creating a variable with a constructor. I can't reuse any of my variables, which can cause a bit of a problem because having to create a new variable every time I do an arithmetic operation just doesn't seem that efficient, and it kind of seems like a pain in the butt for me to do. So one thing that'd be really neat is that I'd like to add additional functionality to the equals operator, so that way the equals operator knows what to do when it gets a point3D class. And, well, I can define that by overloading the equals operator. And here's how I'd go about doing it. And what I'm doing here is that I take the argument p, which will be on the right hand side of the equal sign, and I get all of its getters and I set it equal to everything that my class has. Pretty much element wise, I copy everything over. So p of x gets set equal to our internal x, p of y gets set equal to our internal y, and p of z gets set equal to our internal z. But what is going on right here? So I'm using a special keyword called this. And what this is that it's a pointer to the current class instance. So what I'm doing, so if I have something like this, and I have, for example, let's say a equals b, b is going to be p, and a is going to be this. This is the class that has access to underscore x, underscore y, underscore z in this class declaration, right? So when I have set x, I'm setting a of x to b of x. That's what I'm doing here. And when I return this, well, this is a pointer to the class itself, so I'm dereferencing that pointer. So I return a point3D. So it's a little weird because here I'm setting all the values of b equal to a, but I still need to return it as itself. And why do I need to do this? Well, what if I have something rather than a equals b, but a equals a? One of the tricky parts about the overloading operator of the equal sign is that you have to be ready for these two scenarios. Your class should be able to be set equal to itself and have another number be set equal to the class itself. And by doing it this way, you can guarantee both. Now I've achieved my original complaint at the beginning of this video. And now that I can use the equals operator and set any of my point3Ds equal to any other point3D. So while this functionality is, well, I mean, it's great, it's awesome, I'd like to overload two more operators. More specifically, the double equals and the not equals. If you overload one of those two, you should overload both. If you're going to overload the double equals operator, you should overload the not equals operator. It's just good practice. However, overloading those operators is not always necessary, and I would actually argue that overloading the plus, minus, multiplication, and division operators is not always needed. However, overloading something like the equals operator is needed. I would say it's needed just because you use the equals operator a lot more, as well as other operators that we're going to talk about in the next few videos. So why don't I go about overloading the double equals operator? And I hope that this seems simple. So because an operator, the double equals operator, returns true or false, that's a Boolean type. So I need to return a bool. Unlike previously where I'm returning a point3D with all the other operator overloading, right? However, here the input stays the same. And something else I'd like to note is that when you're overloading these operators, it shouldn't always be the same class. Here, here it's kind of like homogeneous, where it's like the input's going to be the same as the output. But for example, you could have an integer here, and you can set everything equals to that integer and be fine with it, right? You can have something like this, for example, where here I have an integer that I can take in, and I can set everything equals to that integer. You have the power to define these operators how you want them to. You have total control about this behavior, and that kind of seems a little overwhelming and scary, but it's a little liberating because now my classes can be much more flexible than structures could ever be. I could have my const int I here, and I can set every single value to this I and then return this. No problem. I can also take a .3d as an input and set it equal to that. I get to define the behavior and I'm in control. But anyways, let's get back to the double equals operator. So here I have an input of p, which is .3d, very similar to our previous operator overloading functions. And here I'm just doing an element-wise comparison to see if this is equal and this is equal and this is equal. I use a \n to say that, hey, whatever's going on here is going to be on the next line. My statement is going to end on the next line. And it's equivalent to doing something like this. However, having this all in one line may not always be in my best interest, just because, depending on my text editor, it can look a little bit weird. So I usually opt to do something like that. But anyways, let's go about overloading the not equals operator. And I tell you that this is going to be quite challenging, very difficult, more difficult than overloading the double equals operator. And here it is. Oh, so difficult. But this is kind of why you want to, if you overload one, you should overload the other. After you've overloaded the double equals operator, it's not too hard to overload the not equals. Right here, what I'm doing is that I'm exploiting that I have the double equals operator there, and I'm literally taking the opposite. Just like, here I get if they're equal, and then I flip the truth value. Right, so if they're equal here, this exclamation point makes it not equal. So it's very clever. I can do an element-wise comparison here by replacing the double equals just with the not equal. That's fine too, but I opted to do this, which is pretty clever in my opinion. And with these three operators overloaded, why don't we test our program? So now here, instead of redeclaring my classes using the constructor, now I'll be able to just use the equal sign, kind of like I would with integers, right? Here, my goal here is to kind of replicate what I can do, the capabilities of things that I can do, and kind of make it easier to use, more intuitive to use, just like I would use primitive data types like integers, characters, floats, and doubles. That's kind of the goal with overloading these operators. You can add this additional functionality just to make them easier to use. Anyways, continuing, here I'm going to be printing out whether these two are equal, which should be true, and whether these two should be equal, which is not true. Here, it is false that they are not true because they are equal, and here I will get a 1 because E and P are not equal. I need to be careful and put these in parentheses just because C++ is a little weird in trying to grab this and trying to print it out first before trying to do something like that. But this will solve it. And this kind of paves the way for what we want to do next. But let's see the result for this program. And here we have it. So what's really nice is that I was able to replicate what I did with the constructors now with just using the equals operator. And then here I'm able to test my booleans to see if E and T are equal or not equal, and E and Q, previously I said P, but it was actually supposed to be Q, if they're equal or not. And that all works correctly as I expect it to be. But now that we've done this, we've kind of run into another problem of ease of use, let's say. Instead of using print like this is neat, but it's not exactly as intuitive as it is now with C++, now that we have our output streams and now that we're using cout. What'd really be nice is that instead of having something like this, I can have something like this. I think that would be much easier to use and much simpler to use. And it just feels more intuitive now that I've have some experience with C++. Well, we'll tackle that in the next video.